Today our lesson is on linear inequalities. So let's define what a linear inequality is first. So it's similar to a linear equation. Remember, a linear equation is y equals mx plus b. So a linear inequality is similar to that, but instead of using this equal sign, we replace it with one of these signs. So this is less than, greater than, less than or equal to, and greater than or equal to. And then a solution to a linear inequality. So remember our solution, like when we drew a graph, our solution was where they intersected, right? So that's the solution. This time, the solution is all of the ordered pairs that make the inequality true. So you'll see how this is going to be different. Instead of finding the solution like a point like this, it's actually going to be, we're actually going to be shading for the solution to the linear inequality. Okay, so it's all of the ordered pairs that make the inequality true. So let's pretend we have this equation. 2x minus 3y is less than 15. And we want to determine which ordered pairs are solutions to the linear inequality below. So the reason that this is called a linear inequality is because you have an inequality symbol, right? And there's a y and there's an x. Here you have an equal to sign, and there's a y and there's an x, which makes it a linear equation because of the equal to sign. So equation is equal to. Linear inequality are one of these signs, one of these four. Okay, so let's plug in our points. So if we were going to see if this ordered pair is a solution to this equation in linear inequality, we're going to plug in, 2 for x and 5 for y. So 2 times 2, which is x, minus 3y is less than 15. So all I did here was plug in 2 for my x here, and I plugged in 5 for my y. So 2x, or 2 times 2, minus 3 times 5, minus 3y is less than 15. So 2 times 2 is 4, minus 3 times 5 is 15, is less than 15. 4 minus 15 is negative 11. Is negative 11 less than 15? Yes. So this would make, this point, 2, 5, would make that inequality true. Okay, let's plug in negative 1, 7. So if we plug in negative 1, 7, we're going to plug in negative 1 for the x and negative 7 for the y. 2 times negative 1 is negative 2. Negative 3 times negative 7 is a positive 21. Is less than 15. So negative 2 plus 21 is 19. Is that less than 15? No. So that's not a solution to the inequality. So you get the picture here. This is just x comma y, and we're just plugging it in. So 2x, which is 3 this time, minus 3y, which is negative 4, is less than 15. Let's see if this one's true. 2 times 3 is 6. Negative 3 times negative 4 is a positive 12. Is less than 15. 6 plus 12 is 18. Is that less than 15? No. So that's not a solution either. Last one we're going to try is 0, 0. So 2 times 0 minus 3 times 0 is less than 15. This is 0 minus 0 is less than 15. Is 0 less than 15? Yes. So this is a solution as well. So the only two solutions were 2, 5, and 0, 0. Everything else made the equation, both the other points made the equation false. Okay, so what does this all mean? So when we graph linear inequalities, we're going to put it in slope-intercept form. What is slope-intercept form? Y equals mx plus b. Y equals mx plus b. Be sure to flip the inequality symbol if you multiply or divide by a negative number. This is really important. So that's the first step. So if you have to multiply or divide by a negative number, okay, you have to flip the inequality symbol, and we'll go over that. Then step 2 is graph the line, just like you usually do. Okay, you're going to graph the line you're going to start with the y-intercept, and then you're going to do rise over run, just like you would normally. But this time you're going to use a solid line if you have this symbol, oops, that's terrible. Hang on, let me redraw that. If you have this symbol or this symbol, and you're going to have a dotted or dashed line, if you have this symbol or this symbol. So this is a less than or equal to, greater than or equal to, less than, greater than. And then you're going to shade above the line for greater than or equal to, and you're going to shade below the line for less than or equal to. And that kind of makes logical sense, right? You're going to shade above if it's greater, and you're going to shade below if it's less, even if it's equal to. Now, the solid line, look at the keys here. The solid line, both of them have an equal to sign. So if you see that equal to sign, just think of the solid line, go straight through it, right? But it's going to be a dotted line if there's no equal to sign, okay? All right, so let's kind of put all of this together and let's follow the steps. So the first thing, what does it tell us to do first? Step 1, put the inequality in slope-intercept form. That's the same as y equals mx plus b. We're going to do everything the same until we get to the graphing. So watch. And even then, it's not that different. So what's the first step to get it in y equals mx plus b? You have to get the y by itself. So you're going to subtract 2x. That cancels. We have negative 3y is less than negative 2x plus 15. Now what's the next step? We're going to divide by a negative 3. Now what did we read? So, okay, this is y. Now I'm going to leave the sign by itself. I'm going to skip the sign. What is negative 2 over negative 3 equal? That's a positive 2 over 3 x. And then 15 divided by negative 3 is a negative 5. Now, look at this. It says be sure to flip the inequality symbol. Flip the inequality symbol if you multiply or divide by a negative number. Did we multiply or divide by a negative number? Yes, we divided by a negative number. Now this is always going to be in the very last step. So if you want to know if you're supposed to flip the sign, look in the last step. Did you divide by a negative number? Yes, it was a negative 3. So instead of being this way, we're going to make the sign go the other way, like that. Okay? That's really important. It's really important. Okay. Great, so y is greater than 2/3 x minus 5. Now we're going to look at step 2. It says use a, so which one are we looking at? This sign, let's look here. It's one of these two symbols, right? It's a greater than symbol, so we're going to use a dotted line. So I'm going to write that. I'm going to say, because of this, I know it's dotted, and which way are we going to shade? Are we going to shade above or below? Where does this is this greater than sign. It means it's, and think about it, greater than means we're going to shade above. It makes sense, right? We're going to shade above. So dotted and shade above. Now we can graph. Do you see that? Those, actually I guess 3 extra steps. If you divide or multiply by a negative, you flip the sign. Then when you're going to look at the sign and you're going to say, okay, because it's greater than, it's a dotted line, and because it's greater than, it's above. So dotted, shade above. Let's graph it now. So we're going to graph it the exact same way. You're going to graph it, you're going to start with negative 5, and you're going to make a point, because we always start at our y-intercept, and then you're going to rise over run. So up 2, to the right 3, make a point. Now, are we going to use a solid or dashed line? We just said a dotted line, right? So this is what a dotted line looks like. And are we going to shade above or below? Well, we already figured out we're going to shade above, which is above the line this way. Anything that would be down here is below the line. Anything up here is above the line. All right, let's go to the next one. So graph each linear equality to show all possible solutions. Oh, and that's the other thing. On this one, all the possible solutions is literally everything that is going to be above this line. So you could pick 0, 0. You could pick 1, 0, 2, 0, 3, 0. You could pick 2, 2. You could pick 0, 3. But you see how you can't pick anything down here? If you choose anything down here and you plug it into this equation, it's going to turn out false, just like we did up here. Remember when we plugged a couple of these random points in and it became false? Same thing. So look at this line, 2x minus 3y, 2x minus 3y. These are the same lines, right? So let's look at where these points are. This point, 2, 5, is here. 2, 5. That falls. That should work. See how that's one of our yeses. And then 0, 0. That's a yes too. So let's plot 0, 0. And you see how it falls in the shaded region? But what if we plugged in -1, -7? Well, -1, -7 is like all the way down here. Do you see how that's going to be below the line? So that doesn't work. And then here, 3, -4 is also below the line. 3, -4 is down here. Do you see how that's right below the line? So that doesn't work. So that's what we did here when we plugged in these points. We're saying, okay, this and this, those 2 points work for this line. And we could prove it right there. It's part of the shaded part. Okay, so the first step is to put the inequality in slope-intercept form. We already have that in y equals mx plus b. Then we have to use a solid or dotted line and shade above or below. So let's see. We already have it in y equals mx plus b. This greater than symbol, that tells us two different things. It tells us, the greater than symbol tells us to use a dotted line and to shade above. So I'm going to write dotted, shade above. And I'm going to graph just like I usually would. So I'm going to go down 5 right here, make a point. And then I'm going to rise over run. Rise 1, run 3. Rise 1, run 3. Okay. You can also go down 1. Make sure you always connect the line. So connect all these points with a line. That's what I meant to say. Okay. Oh, and I didn't do a dotted line. I did it. So okay. So then before we graph, see, I messed up too. We have to do a dotted line. So it has to be dotted like this. A dashed is probably a better name for it. So you're just like that. Okay. And you're going to shade above. So which way is shading above? Well, anything up here is above the line, right? Anything down here is below the line. So I'm going to shade above. And that's all you have to do. Now on to the next one. Okay, I want you guys to try number 2. Let's try number 3. So now the first step here is to get y alone, right? So how do we get y alone? We're going to do the same thing, minus 5x, minus 5x. Now we have -2y is greater than -5x plus 12. Notice I just subtracted 5x. Do I have to flip the sign if I subtract? Here I subtracted. Do I have to flip the sign if I subtract? No. Notice here it says, where did that go? Be sure to flip the inequality symbol if you multiply or divide. Multiply or divide, not add or subtract. So here, just because we subtracted 5x, we don't flip the sign. But look here, we divide by a -2, don't we? So because it's a negative, we're going to flip this sign. So instead of being greater than, it's less than. And we have y is less than. Negative over negative is a positive 5 over 2x. Positive 12 divided by -2 is a -6. Okay, and then let's graph that. But before we graph it, let's figure out what that sign means. So it's a less than sign. So let's look for the less than sign. Less than means we're going to use a dotted line and we're going to shade below. So dotted, shade below. So -6 is 1, 2, 3, 4, 5, 6 right here. And then we're going to rise 5, run 2. Rise 5, 1, 2, 3, 4, 5, run 2. And we're using a dotted line. And we're going to shade below. So shading below means we're shading down here. Okay, number 4. The first step, step 1, put the inequality in slope-intercept form. So it needs to be in y equals mx plus b. I know it's not equals technically, it's an inequality, but you still want to get it in that form. So minus x, you have negative 4y is less than, keep the sign the same, because even though we minused x, we subtracted x, we don't flip the sign for subtraction. Now we have to see if we divide by a negative, which we do here. Now we flip the sign, so this flips. Now if we divide by a positive, we do not flip the sign. So we have y, the sign flipped. Now be careful here, this is so important. First of all, it's a positive, negative over a negative is a positive. There's a 1 in front of this x, so it's 1 over 4, which is 1/4, not 4. It's 1/4 x. 8 divided by negative 4 is negative 2. Okay, so let's figure out what that greater than sign means. Greater than means a dotted line and shade above. Dotted, shade above. Okay, so let's graph it, negative 2, and then we're going to rise 1, run 4, rise 1, run 4. Okay, so let's draw this dotted again. Make sure it's obvious that it's dotted too, okay? Don't try to, and shade above, don't try to make it kind of a half solid, half dashed line, because I'm not going to give you credit for that. So make sure you know which one you're talking about. Okay, let's see. I'm going to do number 6 with you. No, sorry. Yeah, you try number 5 and 7, and I'm going to do 6 and 8. Okay. So we have to, the first step here, always go back to the directions. We have to put the inequality in slope-intercept form. Okay, so we're going to subtract 3x. So 2y is less than negative 3x. Now we divide by 2. Did we divide by a negative? Nope, so we're going to keep the sign the same. And we have negative 3 over 2x. We do not have a y-intercept, which means we start at 0. Don't let that freak you out. You just start at 0. Then you're going to go rise over run. So go down 3 to the right 2. Or you can go up 3 to the left 2. Okay, now before we draw anything, let's figure out this is a less than sign. So less than means you use a dotted line, and less than means you shade below. So dotted line and shade below. And below means here. And I'm going to write that out too. Dotted line, shade below. Okay, and then x is greater than 7. So think about, where is x equals 7? Where's that line? Well, x equals 7 right here. 1, 2, 3, 4, 5, 6, 7. Right there, right? So let's make a point there. And we have to figure out, is this solid or is it dashed? So let's go back here. The less than sign, or the greater than sign right here, is dotted, and we're going to shade the greater than sign is here above. So dotted, shade above. I don't think we've had a solid line yet, at least in the examples. So we're going to do a dotted line. Now, you know how it says shade above? Think about above. Above means greater, right? So which side do you think would be greater? Do you think it would be greater if we shaded this way? In terms of the x's, are the x's getting bigger or smaller this way? And are the x's getting bigger or smaller this way? So here, the x's are decreasing, right? It's getting smaller and smaller and smaller until the negative infinity forever. It's gonna, if it keeps going this way forever, it's just going to keep getting smaller. But in this direction, it gets bigger. So because we have to shade above, we're actually going to shade to the right, because on this side, we're getting bigger, right? The x is getting bigger. So that's how you can know for when it's a completely vertical line. Okay, so try 2, 5, and 7.